Give me a thumbs up if you've heard this term proportional in math before. Even if you have no clue what it means, have you at least heard it before? Yeah. Some of us, hopefully all of us. Okay. Now because this stuff can be a little bit tricky, we're going to start with it because I want us to start off on a really good note. This is going to come into play every year of math after this. So it's not just important for you to learn this to do well in my class. It's important for you to learn it to do well in all your future math classes in high school. Thank you. All right. So a proportional relationship. We're just going to break it down as simple as we can. Two sets of numbers with a constant ratio. That's that first little space. Constant ratio. That is a proportional relationship. Anyone help me out? What does the word constant mean? Not even in a math sense. So, combo, what does the word constant mean?
Like something that keeps happening over and over again.
Something that keeps happening over and over again. Lola, what were you going to say? The same thing? Okay, so constant. If you're constantly getting in trouble, are you just in trouble one time? No, you're constantly getting in trouble for the same thing over and over and over again. So constant just means it's repeating over and over in the same pattern. Every time Mr. Church gives us a test and I start talking and going on my phone, he sends me out. Man, I'm constantly getting in trouble, right? That's a pattern. If you're always going on your phone, you're always talking during the test, you're going to always get sent out, right? Yeah. So that's what constant means. Now, in a math sense, we'll see what it looks like. Hopefully it makes a little sense. Now, this is a big blank. The relationship has a ratio, and a ratio is just comparing two things, x values and y values, and it's called the constant, which we just talked about, of proportionality. The constant of proportionality. Yeah. How about it? It's a big word, so I'll give you a second to spell it and write it. Constant of proportionality. And there's a letter that we use to represent this constant because that's kind of a long word. I don't want to have to write it every time. Anyone want to guess what letter we use to represent the constant of proportionality? X. That's a good guess. Y. That's another good guess. There's only one more down here. Hey, there we go. The letter K. Lowercase little letter K. K for constant, right? Everybody knows constant starts with the letter K.
Yeah. Wait, what?
I don't know why it's K, but that's, how it is. But think about K constant, all right? And a ratio is just a fraction, right? Ratio is just a fraction. So off to the side here, I want you to actually write that. Ratio equals fraction. Because we see fractions all the time. We kind of stop seeing ratios in like 4th, 5th grade maybe. And then they come back. So it's like, what is that? Well, it's just a fraction. All right? So K, my constant of proportionality, the equation for it is y over x. All right? Everybody repeat after me. K.
Okay.
So that was like 4 people. Repeat after me real quick. K. Equals y over x. All right, real simple equation. I'm not asking you to remember the Pythagorean theorem just yet or anything. This is a real simple equation. What I'm going to do is I'm going to highlight my y in pink. I'm going to highlight my x in yellow. And I'm going to leave k alone. So if I want to find, if I have a relationship or a problem, I'll give you problem number 1. And I say find the value of k, you're going to put y over x. Now that looks like a real simple equation. But whenever letters get introduced into math, it typically throws a lot of people off. Does anyone feel thrown off a little bit by letters in math sometimes? Even if you don't want to admit it, some of us do, right? So I always like to come up with ways to remember these formulas so that they stick. And the way that I like to remember this is the phrase, why aren't you over your ex? All right? Hopefully, y'all don't have too much experience with this question, but you will one day, maybe. Everybody say this phrase out loud. Why aren't you over your ex? Okay, why aren't you over your ex? Again, I'm going to highlight the Y in pink. I'm going to highlight the X in yellow. And I really want to emphasize that over part. Because X comes before Y, a lot of times you want to put the X first and then the Y. We got to do the opposite. We got to ask ourselves every time we do this, why aren't you over your ex? Okay? That's the way that I always remembered it when I was a student. Hopefully that sticks with you. You're going to hear me say it a lot. You'll probably get tired of it. But then again, I'm already tired of hearing 6, 7. So at least you guys have something on me there. All right? Why aren't you over your ex? So let's look at this. This right here is a relationship. What does that look like to you? Even in the most simplest terms. What do you see when you look at this? You see a graph. What else do you see? A line. What else do you see? Letters. What else do you see? Numbers. Good. What else? What's on the line? Dots or points. Okay? And then I have these words down here that explain what my axes are talking about. So, every one of these points, you see I got point A, I got point B, I got point C, D, E. They all have an X value and they have a Y value. And the X values are, what do you think, across the bottom of this graph or going up and down the side of this graph? Where are my X values? Across the bottom or going up and down? Ooh, it was a long summer. My X values are going across the bottom. So I'm going to highlight those in yellow so that I can train my brain to see X values across the bottom of my graph. In this relationship, what do all my X values represent? Number of hours spent in the car. Which means my Y values must be where? Going up and down the side. I'm going to highlight those in pink. And what do those Y values represent? Someone said it over here. The number of miles traveled. Give me a thumbs up if you've ever been on a road trip with your family, in the car, driving somewhere. Okay. Anyone want to share where they went on a road trip with their family? Yeah, Alasia? Los Angeles. Very nice. Johnny? Very nice. Where'd you go, Johnny? All right, anybody else? Where'd you go? Yeah, Ukamba?
Wait, does that mean my family or like with other people?
Other people too.
I went to Las Vegas and Portland.
Nice. Las Vegas, Portland, those are both pretty far. Kayla? Oh, wow. New Orleans to Atlanta? Okay, that's probably like at least 4 hours or something, right? It's not too far. Yeah, Ayana? Minnesota. Ooh, that's a long one. From Sacramento to Minnesota? That's a crazy long one. Johnny, you remember where you went?
Yeah.
Where'd you go?
Las Vegas.
Las Vegas. Very nice. The longest road trip I ever did was from Sacramento all the way to Dallas, Texas. Do you guys know where Dallas, Texas is? Okay. I was like, I want to say I was like 19 or 20, and I went with my mom and my 2 siblings, and we were in the car for 3 days straight. I mean, we stopped to sleep, in the middle, but 3 days straight in the car with your mom and siblings when you're already like a young adult. It was not the most fun. I slept most of the time. I'm a car sleeper, unless I'm driving. I'm sleeping in the car if I'm a passenger, but long time, 3 days. It was like 12 hours every day. So we can all relate to this relationship, right? Johnny, sit up for me. We've all been in the car. I mean, going to school, going to the store. It may not have been multiple hours that we're in the car, but we can understand what this graph is talking about. So as the number of hours in the car increases, see how my hours go from 0 to 1 to 2 to 3 to 4 to 5? You guys see that?
Yeah.
What happens to my number of miles traveled?
It goes higher.
It goes up too. The longer I'm in the car, the longer I'm traveling. That's a proportional relationship. All right? So we got 5 points, A, B, C, D, and E. In this little table here, we're going to figure out what my X values and Y values are for each of those points. So let's start with point A. Where does point A line up on the X-axis? The origin. I love that you said that. The origin. What are the coordinates for the origin? 0, 0. Give me a thumbs up if you remember that from 7th grade. Awesome. That is a great start. So point A is at 0 hours in the car. I've traveled 0 miles. Does that make sense though? Yeah, it does. If I've been in the car 0 hours, I've gone 0 miles. I'm still getting changed. I'm not even in the car yet, right? So obviously I haven't traveled any miles.
But you could go like 30 minutes and still get miles.
30 minutes in the car? Exactly. So take a look. If I were in the car for 30 minutes, that would be this little makeshift point right there, which is still further away than 0, right? But if I haven't started the car yet, I could not have driven any miles, right? What about point B? How many hours in the car have I hours in the car have I been in the car? I don't know what I'm trying to say.
1.5.
1 hour, right? Look at B. If I look directly down from point B, I line up at the number 1. Is that my X value or my Y value? My X. Where does point B line up on the Y-axis though? 60. So after 1 hour in the car, how many miles have I traveled? 60 miles.
Hey, that's a lot of miles.
I know. 60 miles in 1 hour. What about point C? Where does point C line up on the X-axis? 2. How many miles have I traveled if I look over on the Y-axis in those 2 hours? 120 miles. Give me a thumbs up if you see where I'm pulling these numbers from and why I'm doing that. Okay.
The number line.
From the number line, exactly. Anyone ever play Battleship before? You guys know where you put the little ships and then you say, oh, B4, oh, you hit my ship. You know what I'm talking about? Okay. This is just a game of Battleship, right? You see where the point's at, you look down, you look over, that tells me what that point is. Where is point D? What's my X value for point D?
3.
Point D? 3 hours. How far have I gone in 3 hours?
180.
180 miles. And what about point E?
4.
4 hours. How far did I go in 4 hours?
240.
240. All right, that's like from here to like Bakersfield or something if you're driving south. So this is my table. It matches the graph perfectly, right? All these numbers here correspond to the points on there. So what we just did is kind of translate between two languages, the graph language and the table language, but they mean the same thing. If I want to find the value of K, like we talked about, I need to put what over what? Y over X, because we remember the phrase. What's the phrase we remember? Why aren't you over your X? So I'm going to take my Y's, which are miles traveled, and I'm going to put them over my X, which is hours in the car. Again, just so we have it written down, I'm going to put my change in Y over my change in X. Now, what do I mean by change in Y and change in X? Well, let's look back at the table. I started off at 0 hours, right? How do I get from 0 hours to 1 hour? How much time has passed? 1 hour. So my change from this X value to this X value is plus 1. Everybody see what I mean by that?
Yes.
Okay. What about from 1 hour to 2 hours? What's my change there?
2.
From 1 to 2?
1.
I added 1 again. What do I add to 2 to give me 3? I'm adding 1. And from 3 to 4, same thing. I'm adding 1 more. Everybody see what I did there? I'm going to do the same thing on the bottom. How do I get from 0 miles to 60 miles? What do I add to 0 to give me 60? 60. What about from 60 to 120? 60. What about from 120 to 180? Add 60. What about 180 to 240? Do I have the same change in miles on the bottom? Do I have the same change in hours on the top? A repeating pattern over and over again is called, what did we say at the very beginning? Constant. So, this is a constant change in y of 60 miles and a constant change in x of 1 hour. Give me a thumbs up if you just understood what I said. I know it's a lot. Hopefully it's not too bad. So we're going to put them over each other and simplify the fraction. Hey, I learned how to do that, or at least remembered how to do that in the warm-up today. So hopefully it won't be too bad. Okay, again, I'm going to highlight so that I can train my brain to see the difference between y values and x values. All my y's are in pink, all my x's are in yellow. On your table, next to those plus 1s and those plus 60s, go ahead and add the phrases change in x and change in y. Am I going too quick?
No.
Okay. Some of us still waiting to do the little arrows from number to number. Those arrows are super, super important. I can't overstate that enough. Getting those arrows on there with the plus 1s and the plus 60s. Nice. Keep showing those arrows. You know what I mean? All right. So if I look on my table, my constant change in y was what? What did I add every time on the pink? 60. 60 what? $60? 60 miles. I'm going to put my y over my x. What's my change in x from this table? 1. 1 what? 1 hour. Now what I want to do is simplify. We talked about this in the warm-up. If I have 60 over 1, what does that equal?
60 over 1 is 60.
60 over 1. Well, I don't need that 1 on the bottom. I can just get rid of it, and I'll call this 60. There is my value of k, my constant of proportionality. Now, what does this tell me? Well, look at my units. Look at this fraction. What are the units going to be on this answer? Miles/hour. Morning, Jeremiah. What does 60 miles an hour represent?
60 miles per hour.
Yeah, it represents 60 miles an hour. But think about, what are we doing in this problem? We said we're going to Vegas. What is that? We're driving. We're on a road trip. Okay? So what does this value of k tell me about my road trip? How much you drove? Not necessarily. You're on the right track, though.
How many miles it takes per hour?
How many miles I get per hour? Exactly. This is telling me how fast am I going, right? If I'm talking about miles per hour, aren't I talking about speed? So I'm going at a constant speed of 60 miles every hour. Just like we saw on the table. Every hour that passes, I'm going 60 more miles, 60 more miles, 60 more miles. That's a constant speed. Now if I'm going 60 and then I slow down to 20, and then I go up, speed up to 70, and then down to 30, is that a constant speed? No, because it's not the same over and over. But in this case, because this line is nice and straight, that is constant. Quick show thumbs. Is this making any sense at all? It's kind of hard to tell. Thumbs up, it's definitely making sense. Thumbs sideways, it's kind of making sense, which is okay because this can be confusing. Thumbs down, this is making no sense. Okay, good. I appreciate those of you with your thumbs sideways. That's good to know. Go ahead and flip to the second page for me. Because that's a lot of background information. What you guys will be doing is a lot easier than what we just explained. Much, much easier. Can I get a volunteer to read out this first example? Example A. Go ahead, Lola.
Mr. Church, eats 4 French fries per minute. Fill in the table below to represent the number of French fries. All for a given amount of time.
Okay, one more time without anyone else talking. Okay. Guys, Lola's going to read out this example, especially Jeremiah. Listen up. Go for it.
Mr. Church eats 4 French fries per minute. Fill in the table below to represent the number of French fries he can eat over a given amount of time.
Perfect. Thank you, Lola. So, Mr. Church eats 4 French fries per minute. We're going to fill in this table. So, I got a table here. Notice I don't have a graph. I don't need one just yet. We're just going to work with tables today. What does my X represent here? Look at the table. What does the X say?
Minutes.
Minutes. I'm going to highlight that in yellow. My X's are all going to be highlighted in yellow. What does my Y values represent?
French fries.
The number of French fries that I've eaten. I'm going to highlight that in pink. Is there any number in the question that we get that tells me anything important with this problem? I see the number 4. Where is that number 4 going to go on this table? Is it going to go right here?
No, not yet.
Why not? What would go right here? 0. If I've been eating for 0 minutes, I could not have possibly eaten any French fries, so that first little spot is my 0, 0. We call that what again? Starts with the O? The origin. As we'll come to find out this week, all proportional relationships include the origin. But we'll not worry about that today since we're not talking about graphs. All right, let's see. In 0 minutes, obviously I've eaten 0 French fries, right? You guys watch food eating videos constantly on your Chromebooks. I see it all the time. People eating the sushi and the other crazy things that I see. People are eating the octopus and all that weird stuff. If I'm going to do like a food challenge, right? If I haven't started the timer yet, could I have eaten anything? No. So if Mr. Church is doing a French fry eating food challenge, right? Or what is it called? A mukbang? Is that what it's called? Yeah, okay. See, I know a couple things. So if I haven't started the timer yet, obviously I haven't eaten any French fries. But once that first 60 seconds, that 1 minute passes, how many have I eaten at that point? 4. Based on the information in my problem, that tells me some information. Now, if I can eat 4 every minute, 1 minute passes, I've eaten 4. Think about how many would I have eaten after 2 minutes, Vanessa? 8. That's right, I did 8. Or eat. How about 3 minutes? How many French fries could I have eaten in 3 minutes? 12. What did you guys do to get 12?
I ate it.
You added 4. Every single minute that passes, I'm adding 4 French fries. You guys with me on that? Hopefully pretty straightforward, maybe. What about 4 minutes? How many French fries in 4 minutes? 16. So I know I'm adding 4 French fries every time. That's going to be my change in Y. But what changes in x?
The numbers.
The numbers definitely change.
Why?
What do they change by every single box?
Why?
They're adding 1. That's my change in x. I know it's kind of hard to see that yellow. Does that help or make it worse? I feel like that makes it worse. Is that better? All right. So my formula for k, like we talked about, k is equal to y over x. Because of the phrase, why aren't you over your x? So I'm going to create a fraction, also known as a ratio. Vanessa, what's going to be on the top of that fraction?
4, but I have a question.
Yeah, what's up?
For the homework, do we have to like write out the k equals y over x?
I'll show you exactly what to do with the homework as soon as we finish up this page. I got you though, don't worry.
Put 4 fries over.
What was that?
Put 4 fries.
Good, we're going to put 4 fries on the top. 4 fries. Now notice I'm not just putting 4, I'm including my units. Everyone cool on the numerator there, 4 fries? What's my denominator going to be? 16.
Oh, 1.
1. My change in x across the top was 1. 1 what? 1 fry?
No, 1 minute.
1 minute. You guys see? I heard someone go, "Oh," which is great. That's my favorite sound in the world. It means you understand something. 4 fries in 1 minute. How can I simplify 4 over 1?
4.
Just 4. Get rid of the 1. I got 4. Now, what are my units going to be? It's not miles per hour. Vanessa, what's it going to be?
Fries per
Fries per
minute.
minute. Now, you may be thinking, we did all that work when the answer was literally right here in the beginning of the problem, 4 fries per minute. Yeah, because it's not always going to be this simple. I want to start out with some simple things so we can see how these ideas kind of connect. Show a thumbs on that part. Thumbs up, maybe I definitely now understand it. Kind of getting there in the middle. Okay. Now, in the second example, this is what I said. It's a little bit different. We're going to kick it up a slight little notch here. Can I get a volunteer to read out what example B says? Ayana, go for it. Perfect. Every 2 hours, Levi finishes writing 8 pages of his novel. What does my X represent here based on the table? Ukamba.
Your hours.
My hours. I'm going to highlight that in yellow. What does my Y represent? Number of pages written. Most of the time, my X is going to be time. In the first problem, we had hours. The French fries, we had minutes. Now we're back to hours. So my X is usually always going to be time, something to keep in mind. So after 0 hours of writing, how many pages has Levi finished?
8.
8 in 0 hours. 0, 0. That's always how we're going to start these. 0 pages in 0 hours. Now, what information do we get in the problem that I can now translate to my table? Vanessa, what do we got? Okay, 2 hours. I know that's an X because my hours is in yellow. 8 pages, I know that's a Y because my pages is in pink. So what's the first little column of this table gonna say? Well, in 2 hours, he wrote how many pages? 8. Okay. This work is all about patterns. If you guys can start recognizing patterns, it's going to make math so much easier. So here, I'm not even going to worry about these next 2 boxes. I'm going to show you how we can get to them real easily. I'm going to do my little arrows. You're going to hear me say, do your little arrows. again, a million times over the next couple weeks. So we're going to do our little arrows. And I'm going to ask myself, well, how do I get from 0 hours to 2 hours? What do I add there? Plus 2. How do I get from 0 pages to 8 pages? Johnny? Plus 8. Good. So now I'm just going to continue this pattern. If on the top I'm adding 2 hours every time, Vanessa, what should this next box say? 4. Because I'm adding 2. What's this next box going to say?
6.
If I'm adding 2, it's going to be 6. So it's not always going to be 0, 1, 2, 3, 4 on the top. It depends on what the problem says. So if I wrote 8 pages in 2 hours and I double that time, again, I'm just going to follow this pattern. If I have 8 and I add 8, well, how many pages have I written in 4 hours? 16. Good. Thank you. What about in 6 hours?
24.
If I add 8 again, I get 24. Thinking back to what we did, what fraction can I set up now to find k here? Well, I know that k is equal to something over something. What's that? Something over something? Y over x. Good. What's my change in y?
6.
Look at the table. What do my little pink arrows say every time I go?
It's adding plus 2.
My pink arrows?
Oh, wait,
Oh, 8.
it's adding plus 8.
8. 8 what?
8.
8 pages. Thank you. What do my yellow arrows say across the top?
2 hours.
2 hours. Good. 8 pages every 2 hours. How can I simplify 8 over 2? Divide by 2. What's 8 divided by 2?
4.
4. Do I need the one on the bottom? No, so I'm just going to call it 4. 4 what though?
Pages per hour.
Pages per hour. Right? Now go back to the problem. Did it say anything about 4 pages per hour in the written problem? No. It said 8 pages every 2 hours. When we simplify that, we get a constant rate or a constant speed of 4 pages every hour. All right, so it's not always going to be right there in the problem. Sometimes we've got to work for it just a little bit. If I extend this table, I want to know how many pages has Levi written in 10 hours. So I'm just going to add a couple extra boxes here. If I follow this pattern, what should my next 2 boxes on the top say? Johnny? 8 and 10. If I follow this pattern of plus 8, what should my 2 boxes on the bottom be? Yeah, Muhammad?
32.
And if I add 8 again, I get 40. So in 10 hours, how many pages have they written? 40 pages. All right, we're not going to get too deep into that. But it is something I want us to know.